All right, our goal for today is clearing fractions and decimals. We've already looked at a little bit of this as we have been working through elimination. But we're going to dive in just a little bit deeper and make them more complex as you work through the classwork today and as you work through the homework. So, clearing fractions. In concept, you have done this a lot. So, when you had something like 2/3 x equals 6. Well, for this type of problem, we would clear the fraction by multiplying by the reciprocal. And when we multiply by the reciprocal, our fraction on the left simplifies out. Our fraction on the right becomes 18/2, which eventually equals 9. Now the same process looks a little bit different when we have 2x/3 equals 6. And for whatever reason, when we present it in this fashion, students tend to think, oh, I can't multiply by the reciprocal. You still can. There's absolutely no difference from this problem and the previous. However, it looks a little funny to students when they see the x in the numerator, and so we often tend to two-step this type of a problem. Well, two-step is fine. It's still going to get you the same solution, but what we're doing is we're clearing the fraction. So we're multiplying by a value common to the denominator that will allow us to eliminate that denominator completely. So the 3's will cancel out. We end up with 2x equals 18, and we divide both sides by 2 to get x equals 9. Again, no difference in how we're solving the problem. We're clearing fractions by multiplying by a term that will eliminate the denominator. Now, the nice thing about this eliminating of the denominator, it doesn't matter what we multiply by as long as we multiply by a multiple of that denominator. So let's look at the exact same problem. 2x/3 equals 6. Well, 3 is the lowest value that I can multiply by that will cancel out the 3. I could certainly multiply by 6. This just means that when I cross-simplify, I end up with a 1 and I end up with a 2. Well, I need to multiply the other side by 6, and so we'll end up with 36 equals 4x. And when we divide both sides by 4, x is still equal to 9. Now, this also plays on one of the properties that we learned earlier in this unit, a property that allows us to multiply both sides of the equation by the same value, the multiplication property of equality. So let's take all of these pieces and figure out how they apply to the given problem. 2/5 x minus 1/20 equals 3/10. Now, in order to solve this problem, we would have to find a common denominator a number of times. Or we can multiply the entire problem by a value that will eliminate or cancel out the fraction. Now I want to look at what common multiple 5, 20, and 10 will all go into evenly. Well, sure, each of them goes into 20 evenly, so I'm going to multiply by 20. Now, you are certainly welcome to multiply 20 times 2, which is 40, divide by 5, and get 8. However, the process of cross-simplification would tell us that 5 goes into 5 one time, 5 goes into 20 4 times. 4 times 2 is 8. And we'll get the same solution. So I tend to like to apply that philosophy so that we can simplify this problem much quicker. So let's do the same process, just work backwards a little bit. 20 divided by 5 is 4, times 2 is 8x. 20 divided by 20 is 1, times 1 is 1. 20 divided by 10 is 2, times 3 is 6. And all of a sudden, we have gotten rid of all of the fractions and made this a very quick, very easy two-step equation. Add 1 to both sides. 8x equals 7. Divide by 8. X is equal to 7/8. Now, just because we're getting rid of the fraction from the problem does not mean our solution won't end up as a fraction. And if it does, that's fine. Leave it as a fraction and keep moving forward. Now you try. Pause the video, give this problem a shot, and come back and check your solution. All right. We're looking for a common multiple that 8, 3, 12, and 3 will all go into evenly. Well, 8 times 3 is 24. So 8 and 3 will both go into 24 evenly. Does 12 go into 24? Sure it does. So 24 would be the most logical value that I can use that all of my denominators will go into evenly. So let's use our simplification method. 24 divided by 8 is 3, times 3 is 9. 24 divided by 3 is 8, times 1 is 8. 24 divided by 12 is 2, times 5 is 10. 24 divided by 3 is 8, times 1 is 8. And we have simplified out the fractions very quick and very easily. So we can add 8x. We can subtract 8. We can divide by 17. And x will be equal to 2 over 17, which does not simplify any further. We're good to go. All right. Clearing decimals. Clearing decimals is going to follow a similar philosophy. Now, a couple of things we want to remember about decimals. We can change a decimal like 0.50, which we know is half of 1, which we also know when we move the decimal 2 places, that becomes 50%. Now, the part of why it becomes 50% is because we multiplied 0.50 times 100. That allowed us to move our decimal 2 places. So we remember each time I move a decimal, that is a base of 10. So if I move the decimal 1 time, I'm multiplying this value by 10. If I move it 2 times, I'm multiplying by 100. If I move it 3 times, I'm multiplying by 1,000. So let's look at our given problem. Anytime we're trying to clear decimals, we want to look at the decimal that has the most number of values following it. And that's going to be our 3.14 here. How many times do I have to move the decimal point to make this a whole number? Well, I need to move it 2 times. So just as we discussed above, in order to move it 2 times, I'm multiplying that value by 100. In the case of an equation, I'm going to multiply the entire equation by 100. Now, this can certainly make some of your numbers very large, but that's okay. I found that it's easier for students to deal with large numbers than it is to deal with decimals. And sometimes it's just easier to work with the decimals, especially on a small, quick problem like this, but we're just using this one to model. So 100 times 5.2. Again, we're going to move the decimal 2 places. So I should add a 0 after the 2. 520x minus 314 equals 5. Move the decimal 2 places. Will give me 500. All right, now we add 314 to both sides. And notice I'm not dealing with any decimals anymore. And we'll divide by 520. At this point, you're probably going to end up with a decimal solution. 814 divided by 520 gives us x at 1.57. Now, if you wanted to go ahead and simplify it as an exact solution, I would have been fine with you leaving it as a fraction, 407 over 260. I'm not going to hurt my feelings one bit either. General rule of thumb, though, if you start with a decimal, go ahead and end with a decimal. If you start with a fraction, go ahead and end with a fraction. If you start with a mixture of decimals and fractions, like 0.3 repeating, plus 1/8 equals 5. Anytime you have a fraction and a repeating number, you're going to have to change that repeating number to a fraction. So this means we're dealing with a setup that's going to lend itself to fractions. We're going to work with fractions all the way through. We're going to give a final answer in fraction form. All right, why don't you go ahead and give this one a shot on your own. Pause the video, come back and check your solution. All right, hopefully you recognize that our largest decimal term has 3 decimal places, which means we're multiplying the entire thing by 1,000. Every one of our numbers is going to move the decimal 3 places. 1, 2, 3. I will fill with zeros. So 1, 2, 3, and 2 zeros minus 6, 1, 2, 6x is going to be equal to, again, I'll move 2, 3 spaces. 1, 2, 3, and that's going to be a 20. So at this point in time, we will subtract 1, 2, 3, 0, 0. So 12,300 from both sides. Negative 6, 1, 2, 6x is going to be equal to negative 12,280. And so we'll divide by negative 6,126 on both sides. I have a negative divided by a negative, so I know I'm going to have a positive solution. And our solution is 2.00. We'll call that 5 just so that we can see the value and not think it's rounding off at zeros to a perfect division. All right. Now let's merge this with what we've been working with. We've been working with systems of equations. And so sometimes you'll have some systems of equations that have decimals or fractions. And we want to make these a little bit easier for us to use either the substitution or the elimination method. And with either, it's going to be easier to deal with substitution or elimination if we have whole numbers. So, again, I will look through my first equation. It appears that I need to move 2 decimal places. So I'm multiplying the first equation by 100 to make it an equivalent equation, just with whole numbers. So we multiply by 100, and that's going to give me 20x minus 312y, which equals negative 1,772. All right, we need to do the same thing to the bottom one. Looks like I have 2 decimals there, 2 decimals there, so we're going to be multiplying that by 100 as well. So that will move the decimal over 2 places, 11x, plus move the decimal over 2 places, 200y, equals 1255. Now here's where we start to get into larger numbers. Remember when we were talking about using the elimination method? It involved us having a common coefficient. Well, we don't have a common coefficient at this point, which means we've got to multiply again by a value that's going to give us a common leading coefficient. So if I have the values 20 and 11, the only thing that's going to work for me is multiplying each equation by the opposite value. So I'm going to multiply this equation by 11. So 20 times 11 gives me 220. X minus 312 times 11 gives me 3,432y equals, and here's where the number gets really big, 1,772 times 11, negative 19,492. All right, so far that wasn't too bad. Now we got 220x by multiplying 20 times 11. Remember that in order to use the elimination, we want now a negative 220x, which means we're going to not only be multiplying by 20, we're going to be multiplying by negative 20 to make the outcome negative. So negative 20 times 200 gives me minus 4,000y, which is going to equal negative 20 times 1255, which will equal negative 25,100. Now we can finally do our elimination, where our two leading coefficients will cancel out. We have negative 3432 plus negative 4,000 gives me a negative 7,432y, which equals 19,492 and negative 25,100 gives me a negative 44,592, to which we are going to divide by negative 7,432. And we conclude that our value of y is equal to 6. Now, remember earlier this week I told you substitute that value of y in for one of your original equations whenever possible. Sometimes it gets a little bit messier when you're dealing with decimals and fractions to plug things in. This one not so much, because we can use the 0.11x plus 2 times our value of y, which is going to equal 12.55. That's not going to be terribly complicated for us to deal with. So we'll plug in the 6 and that will simplify to 12 equals 12.55, and we'll subtract 12 from both sides, and that's going to equal 0.11x to 0.55. And so we're going to divide both sides by 0.11, and x is going to be equal to 5. And so now we've got our solution 5, 6. You're more than welcome to check. You're more than welcome to check that solution, and I highly encourage it into both of your equations to make sure that you didn't make any mistakes. I'm not going to spend the time doing that now because I want to keep the video a little bit shorter, and I know this solution is correct. All right. Same idea. Now we're dealing with fractions. So our first goal is going to be to clear out the fraction. We got a 5, a 3, and a 10. 5 and 3 is 15. Well, 10 doesn't go into 15 evenly. 10 and 5 is 50, but 3 doesn't go into 50 evenly. 10 and 3, well, that's 30. Does 5 go into 30 evenly? Yes, it does, so that'll work. So let's clean this up. 30 divided by 5 is 6, times 3 is 18x. 30 divided by 3 is 10, times 4 is 40y. 30 divided by 10 is 3, times 123 gives me 369. Again, that didn't take us very long to clean up the first equation so that we were dealing with all whole numbers. Second equation should be a little bit easier. We only have one denominator value. It is 5, so I would multiply each term by 5. Please remember, and if you need to, go ahead and make this look like a fraction so that you do remember. You've got to multiply that 5 to every term. So 5 divided by 1 is 5, times 8 is 40x. 5 divided by 5 is 1, times 2 gives me negative 2y. 5 divided by 5 is 1 times 2, so that's going to equal 2. Now, which term do we want to cancel out? Well, I'm going to have to multiply 40 times 18 in order to eliminate my x's. It seems like it would be a little bit easier to deal with that 2, and how many times does it go into 40? Well, 2 times 20 is 40. So we can multiply our entire second equation by 20 to get opposite coefficients. So let's do this. 18x plus 40y equals 369. 20 times 40 gives me 800x minus 40y, which equals 40. All right, let's combine our terms. 18 and 800 gives me 818x, which is going to equal 409. Divide by 818 on both sides. And x is equal to 1/2. Well, we want to take our value of x and plug it back in to figure out the value of y. Well, where can we plug x into very quickly and easily? I'd probably recommend up here in this bottom equation. So 8 times 1/2 minus 2/5 equals 2/5. 8 times 1/2 is 4. Oops, sorry, I left off my y. Minus 2/5 y equals 2/5. And we need to subtract 4 from both sides. Over here, I'm going to subtract 4, but I'm going to do it in a way that has a common denominator. So 20 over 4. So 2/5 minus 20/5 gives me a negative 18/5, which equals 2/5 y. Which again, we can multiply by our reciprocal. 2's will simplify out, 5's will simplify out. We're left with y equaling. 5's will simplify out. 2 goes into 2 one time, 2 goes into 18. So we have a negative 9 times 1. We have a 1 times 1. Y has got a value of negative 9. It means our solution, 1/2 negative 9. Again, we can check our solution in the other equation and make sure that we did not make any mistakes. I'm going to allow you to do that on your own so that we don't make this video any longer than it needs to be. And that should help you with getting started on your homework. Have a good day.